So to solve this question, which is similar to one of the, but not identical to one of the questions on the homework, I'm going to start by drawing a coordinate system here so that I can make a quick sketch of what this looks like before I jump into math. So let's see. So I've named my axes x and z instead of x and y because the x and z components of the velocity directions are given are non-zero, but the y component is 0. So according to the question, the person runs at 3 meters per second, starts at the origin, and they first run for 35 seconds in the direction 1, 0, 0, which is on the x-axis. So they start here, and they run to somewhere over here. I'm going to call this vector v1 delta t1, so that represents how far they went in that 35 seconds. And then next, from that position, the runner runs for 20 seconds in the direction minus cosine 30 degrees, 0, cosine 60 degrees. So again, the numbers here are different than the numbers in the homework question about this. And the also in the homework question, there are 3 stages the runner goes in, not just 2. So I'm going to sketch this vector on here. Also, x component is negative, z component is positive, so it's going to go to the left and up. I'm sure I'm not drawing the direction perfectly, but gives you the idea. And I'm going to call this piece of it v2 delta t2. And to find the final position, what we'll do is calculate each of these individual vectors, then add them together to get the final position. So let me start with v1 delta t1. So v, we're told the speed is 3 meters per second, and the person runs in the direction 1, 0, 0 for 35 seconds. So the 3 meters per second times 1, 0, 0 is the velocity, 35 seconds is the time, and when I multiply all of that stuff out, I get 105, 0, 0, and the units are meters because meters per second times seconds gives me meters. So let's do something similar for the second leg of this run, the v2 delta t2. So again, the speed is 3 meters per second. Now we're given the direction in terms of some directional cosines. And we run for 20 seconds. So you may know the cosines of these particular angles off your head. You may have to do them on your calculator. Either way is fine. Cosine 30 is root 3 over 2. Cosine 60 is 1/2. Don't forget about the negative side in front of that x component. And then times 20 seconds. If I multiply all of this stuff together, it's 20 seconds. Then I get minus 51.96, 030 meters. So we're supposed to find the final position. The final position is where we went in the first part of the run plus where we went in the second part of the run, and in the homework problem there's a third piece to this. If I take these two vectors from up above that I've already calculated, v1 delta t1 and v2 delta t2, substitute them in down here, I get this, and then add these two together the way that we have been adding vectors all semester, and I get 53.04030 meters. So again, the numbers are going to be different in your version of the homework problem. There are 3 steps to it instead of 2 steps. like I did in this example problem, just to keep things a little bit shorter. Once you have this final position, you can get the average velocity by taking the difference between the final position and the initial position, which in this example and in your homework is the origin, and then divide that by final time minus initial time. In this case, the final time is whatever 20 plus 35 is, that's 55 seconds, so this is the time after you've done all of the running. If you have any questions, feel free to shoot me an email and let me know if you find any mistakes.